right, so we're going to do multiplying and dividing rational expressions. When you multiply fractions, just in general, you multiply straight across. So you multiply the numerators by each other and the denominators by each other. If your rational expressions are only monomials, like questions 1 and 2, go ahead and multiply straight across first and then simplify. If you have binomials or trinomials, factor first, factor everything, GCF, your trinomials, simplify what you can, and then multiply straight across. That's usually the easiest. And when we have binomials and trinomials, you will leave your answer as the separate factors. You don't need to multiply back out at the end. So number 1, we're going to multiply the numerators because these are all monomials. So 6x squared y cubed times 10 x cubed y to the 4th. What is that numerator? $60x to the 5th, y to the 7th. Good. 6 times 10 is 60. When you multiply variables, your exponent rules tells you to add the exponents. And then 2 times 18 is 36. And then the x's, I have x squared and nothing to multiply it by over here, so we just have the x squared. And then I have y to the 4th. All right, now we need to simplify this fraction. So if you go to your alpha y equals and type in 60 over 36 and hit enter, it goes ahead and simplifies it for you to 5/3. And then your x's, we have 5 x's on top, 2 x's on bottom. When we cancel out or subtract those exponents, we're left with x cubed on top. And then we have 7 y to the 7th in the top, y to the 4th in the bottom. So when we cancel out y's, how many y's are we left with? 3. So y cubed in the top. And that's your answer. Any questions? All right, number 2. Multiply straight across. So we do 4 times 5, which is 20. Then I have x to what power? Y to the 8th. 15 times 12 is 180. X to the y to the 10th. Okay. 20 over 18, what does that simplify to? 1/9. Now your x's, you have 5 on top, 5 on bottom. Those completely cancel out. And your y's, what are you left? How many y's are you left with? 2 on the bottom, so y squared on bottom. Okay. This is not 9y squared. Gotta leave it as 1 over 9y squared. Number 3, we no longer have just monomials. Okay. We need to factor. Now, what's the first step in factoring always? GCF. So let's factor everything by pulling out the GCF. So 28x plus 40. What's the GCF there? 4. And when I divide by 4, I'm left with 7x plus 10. What's the GCF of 35x plus 50? 5. Left with 7x plus 10. You have to put the GCF on the outside. A lot of people, when we were just simplifying, you just wanted to divide by 4 and not put that on there. You have to include your GCF. It doesn't just go away. Now over here, 12x plus 24, what's the GCF? 12, leaving you with x plus 2. And 8x plus 16? 8, leaving you with x plus 2. Once we have completely factored, we see what factors can be canceled out. So you can cancel out basically anything that's being multiplied is a factor. So 4 is a factor, and then 7x plus 10 is a factor. 5 is a factor, 7x plus 10 is a factor. And you could only cancel out complete factors. So we can cancel out these 7x plus 10s and these x plus 2s. And we get 4/5 times 12/8. And you just type that in the calculator. What do you get? 6/5. All right, number 4. Factor everything. So in the top, do we have a GCF? 5x. And that leaves us with 2 minus x. Do we have a GCF in the bottom? No, but it's a trinomial. So we can find two numbers that multiply to be 18 and add to be negative 11. Yep, x plus 9, x minus 2 times. In the top, on this fraction, do we have a GCF? Oh, wait, no, not x plus 9. It's x minus 9, yep. They're both negative. Because negative 9 and negative 2 make negative 11. And negative times negative is a positive. Yep. What over here multiplies to be negative 9 and adds to be negative 8? Negative 9 and positive 1. And then 15x is just 15x. Is 2 minus x the same thing as x minus 2? They're not the same thing, so you can't just cancel those out. However, I'm going to show you how we can manipulate that a little bit. So over here, if I have 2 minus x, this is the same thing as negative x plus 2, right? I just switched the order of those. Does that make sense? What if I factor out a negative 1? What am I left with? Not x plus 2, it would be x minus 2. So what I can do is change this. I'm going to put this the negative 1 in front, and then I can change this to x minus 2. Now, anything from any of the numerators can cancel with anything in any of the denominators. So they don't have to be on the same fraction. So these x minus 9s can cancel. And now I have an x minus 2s that cancel. And so that leaves me with negative 5x and then an x plus 1 in the numerator and a 15x in the denominator. Can I simplify any more? Yes, this negative 5x, this is really negative 5 times x plus 1. So I've got 3 separate things, 3 separate factors on top, and 15 times x on the bottom. So we can cancel out these x's. And then this negative 5 over 15 will simplify. What does that make? Negative 1 over 3. So this will be the negative x plus 1 over 3. Questions? All right, number 5. First fraction. Do we have a GCF on the top? 4x, leaving me with x minus 1. Is there a GCF in the bottom? 2. Leaving me with x squared plus 2x minus 3. And then that will go back and factor down again, so we'll have to go back and get that. Let's go to this other fraction. Does that top have a GCF? No. So we can go ahead and split that one up. What two numbers multiply to be negative 6, but add to be positive 1? X plus 3, 3, and then the negative 2, x minus 2. Then the bottom, does that one have a GCF? 4x, leaving me with x plus 2. Now this fraction over here, this denominator, can factor some more. So everything else stays the same. Now, if you could, in this step, if you can take out the GCF and break this down, you wouldn't, I don't expect you to rewrite this, but you can if it helps. So what two numbers multiply to be -3 and add to be +2? +3 and -1. So x plus 3, x minus 1. And now I can cancel out common factors in the numerator and the denominator. So we have x minus 1s. We have x plus 3s. We have these 4x's. Anything else? I have an x minus 2 and an x plus 2. We can't manipulate those to get a common factor. So I've got x minus 2 on top, and then 2 times x plus 2 on the bottom. And you can check your answers here. Type in a number for x, type in your question and your answer to see if they match. Now you will need to avoid, if you're going to store numbers, sometimes it might give you an error and say you can't divide by 0. If you would have plugged in a -2, a 1, or a -3 for your x, any of those would have caused you to get a 0 in the denominator and it would give you an error. So if that happens, just try some other number to see if they match. All right, number 6. X plus 10, does that have a GCF? No, nothing you can do there. Now this one is a 9 minus x. I'm going to guess that it's going to be similar to this one we had above, but we'll wait and see if we need to swap it out and change it a little bit. X squared minus 5x minus 36. Does that have a GCF? No. What two numbers can you multiply to be -36 and add to be -5? -9 and 4. Does the denominator have a GCF? 4x, leaving me with x plus 4. And so, yeah, I do have an x minus 9 and a 9 minus x. So, if we would go back over here, 9 minus x, that's the same thing as having -x plus 9. Just switching the order, which is the same as having -x minus 9. Any questions so far? All right, let's cancel out factors. We had x plus 4, x plus 4. X minus 9, x minus 9. Now this x plus 10, that itself is a whole factor. Two things that are being added together, that's considered a factor. So that leaves me with x plus 10 on the bottom and negative 4x, or x plus 10 in the top, the numerator, negative 4x in the denominator. What's something that I should probably do here? Do what? The only thing we can do is take the negative out. You cannot make this 5 over 2 because you would have to be able to simplify all parts of this. Like this x would have to have a even number in the front. But we can get rid of the negative. We can make this a positive, this becomes a negative, and this becomes a negative. Are there any questions? We're going to do some dividing, and it really just has one extra step at the very beginning, and then it's just like the ones we've been doing. So when you divide fractions in the past, do you remember what you did? Anybody remember? That's if you're adding or subtracting. When you're dividing, do you all remember keep, change, flip? Or something like that? Yeah. So you keep the first fraction, change it to multiplication, and then flip the last fraction. Now, we don't really use keep, change, flip in Algebra 2. That's a little bit more simple. We're going to use some fancier terminology. When we are dividing, we say that we multiply by the reciprocal. So we multiply the first fraction by the reciprocal of the second. Reciprocal just means they're flipped upside down. So this is number 7. This is the same thing as having 5xy over 16x cubed times 8y to the 5th over 35x squared y squared. So we changed it to multiplication and you flipped the last fraction. And then it's a problem just like the first 6. These are monomials, so the easiest way to do these is go ahead and multiply straight across and then simplify. It's usually less work that way. So when we multiply straight across, we do 5 times 8, which is 40. There's nothing to multiply the x by, but we have y to what power? 6. And then what is 16 times 35? 560. X to the 5th, y to the 2nd. Good, because this one y squared, there wasn't anything to multiply it by over here. And then we simplify. What does 40 over 560 simplify to? 1 over 14. X's, we have x on the numerator, x to the 5th on the denominator. When we cancel out and simplify, what do we get? X to the 4th on the bottom. And what do I get when I cancel out or simplify the y's? Y to the 4th on top. Good. And I don't usually leave a 1 in front. If there's also a variable, you really don't need the 1. It's not wrong if you leave it here, but I don't like to do that. Y to the 4th over 14, x to the 4th. Now, if that y to the 4th wasn't there, we would have to leave the 1. Number 8, Let's rewrite this and make it a multiplication problem. What do I do with this one? Yes, we would put a 1 over it. So this technically has an imaginary 1 under it. So when I do the reciprocal, that 1 would be on top. So it would be 1 over 10x plus 70. So these are not all monomial, so we need to try to factor. Is there a GCF in the numerator? 2x. And I've got x plus 7. What about a GCF over here? 10, leaving me with x plus 7. The only parts that cancel are these x plus 7s. And I get 2x over 8y squared. Can any of this part simplify? The 2 over 8 can simplify. What is 2/8? A fourth. So this would be x over 4y squared. Oh, yeah, sorry. That should have been 80. So what does 2 over 80 simplify to? 1 over 40. So this would be 40. Thank you. Any questions? I want you to work on questions 9 and 10 by yourself. All right, so number 9, we have 10 over 4 times x minus 2 times. Now this one, I'm going to go ahead and factor it and flip the fraction at the same time. So this one factors into x plus 3, x minus 2. And then we have a 2x, x plus 3. My x minus 2's cancel. My x plus 3's cancel, leaving me with 10 over 8x, which is 5 over 4x. Questions on that one? All right, number 10. All right, this 1 minus x squared, this one is a difference of squares. You could just leave it, your a is 1 and your b is x, and this would factor into 1 plus x, 1 minus x. And then the bottom, there was a GCF of 2 times 6 over 2x minus 1. This one down here will factor. If I do a minus 6 and a positive 1, Is 1 plus x the same thing as x plus 1? The plus, yes. 1 plus x and x plus 1 actually are the same thing. 2 plus 3 is the same as 3 plus 2. So this one is x plus 1. How can I fix this one so it's x minus 1? Take a negative. It would be negative x plus 1, like we did on the back, and then you factor out the negative. So just like we did before, let's see over here. Negative x plus 1, negative x minus 1. So if I put a negative out front, I can make that an x minus 1. So then my x minus 1s cancel. My x plus 1s cancel. And I've got negative 6 on the top, and then 4 times x minus 6 on the bottom. Can I cancel out these minus 6s? No. This is x minus 6. Oh, you can't see that. That x minus 6 goes all together. You can only cancel out an x minus 6 and an x minus 6. But you can simplify the numbers in front. What does negative 6 over 4 simplify to be? Negative 3 over 2. There you go. And that was a very tough one. Any questions?